Yes, for sure. I can do written too, yeah. Just put them like maybe over here so they're in a different place, yeah. Okay, so for number 44, we have equal moles of H2 and Br2 were placed in a flask. And at equilibrium, we know that the HBr was 0.5 moles per liter. So when it says were placed in a flask, or were mixed in a flask, or anything like to do with putting them in a flask, that tells you those are your initial quantities, and obviously this is our HBr at equilibrium. So technically this is kind of like a race table, but not really, okay? So what we're going to do is we're going to write out a rice table. Yes, you can. We're going to write one. Normally, if I was doing this like on a multiple choice, I wouldn't bother with all my little square brackets because that takes a lot of time, but I'm doing it just to be thorough for you guys. Okay, so we have H2, we have Br2 in equilibrium with 2HBr. Now, our initial concentrations, we don't know, it just says equal moles, right? So we don't know what that is. So let's call that I don't know and I don't know, but those two are equal to each other, yes? It says nothing about the HBr, so what's the initial concentration of HBr? 0. Excellent. And we know that the equilibrium concentration of HBr is 0.500 molar, yes? Now, these are going to be like minus 0.250, minus 0.250, but to be honest, it doesn't really matter. Let me make this bigger. Because the thing that matters here is that these two at equilibrium are still the same as each other. So rather than having question mark minus 0.250, why don't we just call these both x? Because if they are the same, then I have one value for x, and I have a concentration of an HBr, and hopefully somewhere in here there's a KEQ. There is. My KEQ is equal to 1.02. So we can then write our KEQ expression. KEQ is equal to the concentration of HBr squared over the concentration of H2 times Br2. And so that's going to be 1.02 is equal to 0.500 squared over, and these two are, we don't know what they are, but we know that they are equal, and that's what we are looking for. So that's going to be x squared. You do a little algebra, you end up with x squared is equal to 0.500 squared over 1.02. Anyone want that algebra broken down any further? We're good? Okay, 0.5 squared divide by 1.02 equals 0.245. And now I want you guys to be careful because 3 times yesterday I made a mistake. And my mistake was I was like 0.245. Oh, look, there's a 0.245. I am done. I was so excited. And then someone was like, hey, hang on, isn't that x squared? And don't you want to have x? And I'm like, oh. So don't make that same boo-boo that I made. You want to find here x. So that's going to be the root of 0.245. Yeah, it would be easier if you didn't have multiple choice. That's why multiple choice are sometimes nasty, because they'll put in those things where it's like, oh, I forgot to, right? And if it were written response, you could get part marks, but in multiple choice, you can't. Oh, they're not nice. So yeah, it would be 0.495. Is good? Okay. We also have here number 45. K-trial is just Q. K-trial is the same as you'll sometimes hear it called a trial KEQ, which is the same as Q, okay? And so we have 0.5 moles of O2 and 0.7 moles, or sorry, of O3, 0.7 of O2 in a 1 liter flask. So our Q value, products, which is O2 cubed, over our reactants, O3 squared. But what makes this different from a KEQ? Those are our initial quantities, and so we're going to use these ones that are introduced into a flask. Those are our initial quantities, and it's in a 1 liter vessel, so the moles are the same as the molarity, right? Because it's just moles divided by 1 liter. So we're going to have O2 is 0.70 molar, and in fact I'll get rid of the molar because KEQ or Q does not have a unit. And we have 0.05 O squared 0.7 cubed divided by 0.05 squared equals 137.2. Okay, what do we do with our Q value? Compare it to our KEQ, which we are told is 55. So Q is bigger, which means that our products over reactants is too small or too big? Too big. Yes, because it's bigger than we want it to be. It's too big, therefore we need to shift. Are we shifting towards products or away from products? Therefore we'll shift away from the products towards the reactants. And that means we are shifting to the left, which means our concentration of O2 should be increasing or decreasing. If we're shifting left, O2 is decreasing. So it's got to be either C or D, and we already know that Q, which is K trial, is greater than KEQ, so that's going to be this one, so the answer should be C. Number 58. Equal number of moles of I2 and Br2 are placed into a closed container. KEQ is equal to IBr squared. Why am I writing that? I need a rice table is what I need. I2 plus Br2 in equilibrium with 2I Br. Oh, which of the following relates IBr to I2 at equilibrium? In fact, I don't need a rice table at all. What does our KEQ value tell us? KEQ is bigger than 1. Therefore, our products are favored. Therefore, it doesn't matter what happens at the beginning or in between. All that matters is at the end we will have more product than reactant, which means that IBR is going to be greater than I2, which is this one. All right, and we wanted written response number 5. Oh, that looks promising there. Where did it go? Come back here. There we go. The value for the KEQ is 0.8. A particular mixture has the following concentrations. Show by calculation that this mixture is not at equilibrium. How are we going to show that it is not at equilibrium? You are going to find not KEQ, but Q. Because Q will tell you if you are at equilibrium, and if not, which way you are going to shift. Okay? So that's going to be NO2 initial times SO2 initial over SO3 initial times NO initial, which is, let's see, NO2 is 0.6, SO2 is 0.45. You'll notice I'm playing fast and loose with my sig figs here because I'm just trying to get an answer really quickly. If this is a written response, though, you should always write down all your sig figs in your work. Yes? And then we have SO3, which is 0.4, and NO, which is 0.48. 0.6 times 0.45 divided by 0.4 divided by 0.48 equals 1.406. So you would say Q doesn't equal, for this question, you would say Q does not equal KEQ, therefore we are not at equilibrium. Yes? What will happen to the concentration of SO3 and SO2 as the system moves towards equilibrium? Well, in addition to it not being equal, Q is bigger than KEQ. Therefore, our product over reactant is too big. Therefore, it's going to shift to the left to make more reactant and use up some product. And once we know that if we are shifting to the left, the concentration of SO3 is going to go up. And the concentration of SO2 is going to go down. Is good? Okay. Any other questions? All right, shall we take a look at part